Okay, so I've written the spider, if you've been following along with the previous videos. I've copied the spider across onto my Raspberry Pi because I can leave that on 24/7 without melting the ice caps. And I've got some data already generated by it. I've tested it and it works. And if I just move this slightly, you can see 4 different timestamps. So I've scraped Amazon for web scraping books 4 times already. So I'm just going to demonstrate that again. And then we will have 5 lots of separate scrapes all stored with 5 different timestamps, and then I will move on to analysing the data and write some SQL statements. So if you're ready to watch this, then we'll just quickly set this up and get it running. Helps if you put Scrapy before crawl. Let's go. Hopefully this will work, otherwise it'll be a bit embarrassing, won't it? I'll probably run this a few more times, but I'm at the point now where I can actually start analysing the data. I found, good, it's working. So I found some SQL which does what I need to do, which is pick out any books, because we've scraped for web scraping books, it picks out any books that have had their price change since we've been scraping. If their price hasn't changed, then we're not interested and we just want to ignore it. And I've found some code on Stack Overflow which uses partition by, and it also uses something called LAG. Now, I'm not an expert on SQL, as you may have noticed, so there's going to be a bit of fun and games getting that to do exactly what I would need it to. However, once I've done that, and I will be showing that, once I've got something to show you, we'll look at that, we'll run the query, and then hopefully we'll have some sensible data that we can use with Pandas and Plotly, and we can generate some meaningful visualization of price tracking, which is what we're doing. We're tracking the price of web scraping books on Amazon over a period of time. The period of time is not critical really, we just want to prove that over several days or several weeks we can identify which products have prices that change. So there we go, that's finished. So instead of each author having 4 timestamps, if we just refresh the view of the database in PHP-MyAdmin, I'm hoping, if I just do title again, we should have something for, today's date is, in the UK we say the 10th of November 2020, so 10th of the 11th month. And the timestamp is the other way around, so I'm looking here for 10th, reading it backwards, so the 10th of the 11th 2020. So as we can see, I have just scraped a paperback book called Introduction to Text Mining, and the price has not changed. And not many have, but some have, which is good, because otherwise we would be producing some pretty meaningless graphs just with a straight line. So yeah, I've got 5 timestamps now, as you can see. So the next time I will show something will be when we are starting to query the data. Okay, so next part. I've got some data. As you know, I've got 5 separate runnings, 5 separate scrapes, and we're now in PHP-MyAdmin, so this is nothing to do with Python, but I promise we'll get back to that. And select, so Amazon Books, we're specifying the name of the table, dot star, so that's everything. So select everything from the Amazon Books table, select the Amazon Books table. From the Amazon Books table, we then go and do all this. I'll come back to that in a second. And then we are selecting, that's quite easy, easy to understand, and we're selecting where the previous price is not the same as the current price. Now, we haven't, as you look over here, we've got price, but we've not actually got previous price. Where does previous price come from? Well, that's what we make within this select statement. So, lag price over partition by title, order by posted. Posted is what I've called the posted date, when the time is effectively the timestamp. It's my word for timestamp. So as previous price from Amazon Books 2. So we're creating the previous price within the select statement, and then we're saying if the previous price is not the same as the stored price, then we want to find it. Let's run it. And it's only actually found 7 results. That's promising. And let's just scroll out a bit so you can see the previous price. What we've got here is okay. I see. So although they look the same, we're not comparing those two. They are separate books. If you look approach to comp. I thought they were separate books. I don't know why they've come up twice. All the others are just once. Anyway, that is something for another day. Social media, finding stories, mining the social web. They're all different authors apart from this first one. Okay. Anyway, if you look here, price was... Oh, I see. It's changed twice. That's why it's appeared twice. Okay. So originally it was on the 9th of November. It was changed to £92.19, and previously it was £92.31. And then today it's been changed to £92.01, and as we know, on the 9th it was £92.19. So that's interesting. We've got the same book, but it's occurred twice because the price has changed twice. And all of the others, it appears, only occur once because their price has only changed once. So we have £23.02, which it was previously, and now today it is £30. So they've put the price up by £7.41, which is quite a lot. One of the reasons why I wanted to do this, because I'm wondering if they put the prices up slightly before Black Friday. So this is not really confirming or denying my suspicions really, because one book has come down slightly. This book has jumped up a lot. This book has gone from 35 down to 32. This one's gone from 35.30. This one's gone up by 55p. This one's gone up by £7.03. And this one has gone from previous price £12.99 to £12.18. So we could make various graphs of this. We could show a bar chart with the previous price and then the current price over the top of it, or in fact, I'm surprised by how few have changed, but we're only selecting from, I think it's about 180 that we find on our scrape. If we go up here, how many items? Yeah, because we drop 81 because many are for Kindle or hardbook, and we're just picking out the paperbacks. So potentially I could go in and change that. Really, the reason why I was picking out just the paperbacks, because I was testing out process item in Scrapy.pipelines. Okay, so we've got some good data anyway, which is a success. And go to get autosave query. I'll just zoom in on this so you can see it, and you might want to pause it, and you may want to copy my code. So if you do, then feel free to use this. Don't ask me to explain it. So basically it's a select from where, which is standard SQL, but this bit in here, partition by is effectively similar to group, but it's different. But anyway, moving swiftly on, I'll be back soon with the next part, which will be presenting and visualizing this data. So until then. Okay, so where are we now? We are looking at MySQL my.cnf. It's a config file, and upon testing, I had this error, can't connect to MySQL server on 192.168.1.7, which is the correct IP address because it is. It's working with my PHP myadmin and so on, and I'm SSH'd into it at a pi, so I know the IP address is correct. So it's going to be an issue with the port, i.e. firewall blocking it or some other such issue. So quick check on Stack Overflow, and we have this OpenTCP ports on Raspbian, and although this is Raspberry Pi, this applies to any Linux and even potentially a Windows client server. Sudo nano etc. mysql.my.cnf, and you need to do bind-address equals 4 zeros, which is what I've added here. Previously that line was not in this file. So this file is as it was for default, but with the addition of that final line. So when I've added that, sorry, and exit. The next command to run is netstat space -an, then pipe, and then you want to grep TCP. And if you can see the difference, if you look at, we're looking for 3306 because that's the port that MySQL runs on. Previously it was using 127.0.0.1, that was what the bind address, and now we've changed it in that file, and now we can see it's binding to this. And when I tested it, I actually got, instead of the error, I actually got a Pandas data frame, which is good. You may recognize this from a previous video. So that's my starting point, and now I've got a connection. I can retrieve data from MySQL. The previous video I did, I was extracting it from the local host. So the difference here is that I'm connecting to a remote SQL server, and I'm loading a data frame from the remote SQL server, and I'll be back with the next section. Hello. As you can see, we are now on the home straight, coding a price tracker in Python, and we are going to extract the query data and visualize it. Now, for those Windows fans out there, you'll be pleased to know that this is no longer exclusively a Linux tutorial or Linux project, because what I'm going to do is write all this and run it in Sublime Text on my Windows 10 PC. And it would work just as well on Linux. This is a Python script. So app.py, make a graph from SQL data from Scrapy. From Scrapy and MySQL, that should really say. Import PyMySQL, that creates a connection to the database. Import NumPy as MP, import Pandas as PD. From Matplotlib, import pyplot. as PLT, import Seaborn. Seaborn's kind of the theme, SNS.set. Okay, query. This is the bit you saw earlier. The query, I think it was daylight still when I did that. So yeah, I've had a busy day. Select amzbooks2.star. So that's the table, my table name. And this is the query where we are using lag and the partition by, and we actually end up with a new field called prev price, and where the previous price is not the same as the current price, we get it's true, so then we get a result. We'll use that query in a minute. So line 17, dbcon, we're just creating a connection object or connection to my server, which is a Raspberry Pi 4, but it could be any kind of server. User 1, password 1, username, password, and that is the name of the database. The database itself is called AMZ. The table is AMZ Books 2, if you've been following along. I've made a function, genPlot, it generates the plot. I've got a query which then reads it uses Pandas. Pandas does the query using the dbcon connection. I create a data frame called AMZ data, which picks out the ID, the title, the price, and the previous price from the table. We do the Matplotlib fig, and so figure and axis equals plot.subplots method. We're creating two bars here. So R1 is the previous price, and that will be in green. The reason for that is if it's in green, it will be, if the previous price is greater than the current price, the previous price bar will be higher, and then you will see a little bit of green above the red, and the current price is red. So if the current price is higher than the previous price, you'll just see a red bar. It'll make more sense when you see the plot in a second. PLT title, that is just the name of the, what's the title? What you see on the end product. Plot xticks, and here I'm using, so we're mapping the Amazon data.index, which is the data frame index, so 0, 1, 2, 3, 4, 5, 6. We're mapping that to the Amazon data title, so that's the book title, which started off a couple of weeks ago. That started off as the first thing I think that I scraped from my Scrapy spider. Color equals green, that's the color of the text. Rotation 10, if you have it like that, all of the text overlaps. If you rotate it a bit, you can see it all nicely aligned. Again, that will make more sense in a second. Horizontal alignment, right. The label, X label, vertical label is the price in dollars. Plot legend, plot.show. And then I've done a main driver, connects to the database, and then it runs the genplot function. If we get an error, then it tells you. And then finally, we close the database connection. Here in that terminal, you can see I've already run it. So if you'd like to see it working, let's run it again. And yeah, let's go. So Control S, just make sure I saved it all. Control B to build. And it may build it on my other screen, but I'll drag that back across. It takes a few seconds to run. So there you can see, that's the print AMZ underscore data. So line 24 there has created all this. And here's the moment you've all been waiting for, and we have a plot, a relatively meaningful plot. And these prices have changed so by such a small amount. I think they've changed by, yeah, so the first two bars are data science in R, where the price changed by, first it changed by 12p, and then it changed by 17p, so that's why, yeah, there would in theory be a tiniest little, has it gone up or down? Previous price, yeah, so it keeps coming down in price. In theory you would see two tiny little green lines, but it's probably less than a pixel. Number 3, mining social media, which is that one. The price has actually gone up by over £7, so that's why that's just red. Now this is the interesting one. Mining the social web, the 4th bar along, index 3, that's actually the 4th one because we start from 0, and that's the one that's got sorry about that, moved the mouse. That has changed from £35.21 down to £32.21, so £3 reduction. So the previous price was up there and now it's down there, so that's why it's got that little bit green, because you're seeing the difference between the red at 32.21 and the green, which was 35.21. And then we've just got the others, and there's a tiny little price reduction on that end one, which was called The Hitchhiker's Guide to Python. Let's I'll just make that larger for you. And in Matplotlib you can do these adjustments with these little sliders, so I'll just demonstrate that if you've not seen it before. So you can just shift that across, and basically you're just repositioning it to format it a bit more better, as we would say here in rural England. Yeah, so there you go there, and it's just making it a little bit bigger, and it's exaggerating the green. So yeah, again, that's not even a pixel up there. So I think that's pretty good though. I mean, we've got, what we've really done is we've visualized something which was based on what we've web scraped from Amazon, based on web scraping books. And next step would probably be, I may well do this, would be to, rather than drop the Kindle books and the hardback books, I might, now that I've kind of demonstrated process item in pipelines.py, I might leave that out and scrape everything, and I won't drop anything, so then we'll have a much larger sample size. And also I will leave, well, I'll amend it and then I'll leave it running on my Raspberry Pi for a week or so, and then hopefully we'll have some meaningful data across approximately 200 books, and then we can see whether anybody's putting their prices up before Black Friday, and we'll know if they are doing that so that they can reduce it or make it look like they've reduced it. So I hope this has been interesting. It's been quite a big project, and really this is, I may do one more video on this, but I think I've pretty much covered everything I need to here. So what we've done is we've web scraped Amazon using Scrapy. We've used Scrapy because it is, well, what were the choices? The choices were to use requests and write our own small spider and handle all of the database, but Scrapy is asynchronous, which means it can be getting on with other things while it's doing the first request. And yeah, if you've seen videos on Selenium, I would recommend learning Scrapy if you're going to be doing this in any serious fashion, because Selenium is really for testing, and Scrapy is, as I said, asynchronous, and it will be so much faster, and it's kind of the right way to do it. So on that note, I will say goodbye until the next video. Please subscribe, blah blah blah, what is it, thumbs up, like, comment, all that. Cheers, just for you know, because algos.